Welcome back to the Explainer. $700 billion. Yeah, you heard that right. That is the staggering, almost unbelievable estimated financial cost of a 1986 Chernobyl nuclear disaster. Just wrap your head around that number for a second.
So it really begs the question, what on earth causes an engineering failure of that sheer magnitude? Now, you might automatically assume, oh, it's got to be just a technical glitch, or maybe a faulty wire, right? Well, not quite. As we dive into the data today, it becomes incredibly clear that it is rarely ever just bad math. Actually, scratch that, it's almost never just bad math. It is usually something much, much deeper.
Today, we're unpacking the massive financial and human costs of historical engineering failures. We're going to explore how systemic human factors, we're talking relentless cost-cutting, organizational silence, and just pure institutional hubris, can literally turn solvable, everyday technical flaws into historic, world-altering tragedies.
To give us a roadmap, here's the structured root cause analysis we're going to use today to guide our learning. We'll kick things off with profits over public safety, then move right into the normalization of deviance. After that, we'll examine hubris and ignored warnings, scale things way up to massive industrial catastrophes, and finally, we'll wrap up by looking at the essential quality control lessons these disasters left behind.
All right, let's jump straight into Section 1, Profits over Public Safety. When budgets dictate safety, things go wrong. Time and time again, the sources show us that rushing schedules and aggressively cutting costs almost always lead to absolutely catastrophic outcomes. The Boeing 737 MAX is, unfortunately, a textbook illustration of this exact point. Back in 2010, Boeing really rushed the development of this aircraft just to keep up and compete with Airbus. And instead of building a completely new airframe from scratch or, paying for extensive pilot retraining, they opted for a software fix, a system called MCAS. They essentially prioritized cost savings over comprehensive testing and manual documentation. And the tragic result? 2 horrifying crashes, Lion Air 610 in 2018 and Ethiopian Airlines 302 in 2019. That resulted in 346 deaths and a completely devastating $42 billion wipeout in Boeing's market value.
But hey, this danger definitely isn't limited to just aviation. It absolutely plagues public infrastructure too. Just look at Boston's Big Dig. It is literally the most expensive highway project in American history. Now, originally it was estimated at a cool $2.56 billion, but thanks to this incredibly complex web of integration problems, uncharted utilities, and totally unforeseen subsurface ground conditions, that cost skyrocketed. I mean, it exploded to nearly $15 billion.
But, the financial overrun really wasn't the worst part of the Big Dig story. Under extreme mounting cost pressure, project management started eliminating crucial safety margins. Specifically, to save some money, they reduced the number of anchor bolts used to hold up these massive, heavy concrete ceiling panels by a whopping 40%. This massive reduction, combined with a faulty epoxy adhesive they used, led directly to a fatal ceiling collapse back in 2006.
It really goes to show that pressure to deliver can have lethal consequences. Which makes me wonder, have you ever felt pressured to cut corners just to meet a super tight deadline? I mean, we've all been there at work, right? Tell us your experience in the comments. It is a highly relatable human experience for sure, but as we've seen on a mega project scale, it proves absolutely deadly.
And that brings us right into Section 2, the normalization of deviance, or basically accepting the unacceptable. This section is all about how accepting small, everyday anomalies over time slowly creates a sort of invisible culture of disaster.
This brilliant term was actually coined by sociologist Diane Vaughan during the investigation into the Space Shuttle Challenger. So, the normalization of deviance happens when people get so incredibly accustomed to a flawed behavior or some technical deviation that they literally stop seeing it as dangerous. They don't consider it deviant at all anymore. They just accept it as normal operating procedure, despite the disastrous consequences just waiting to happen.
You can see this glaringly during the Space Shuttle Challenger disaster. There was this massive, almost unbelievable disconnect within the organization. The engineers on the ground, who actually knew the O-ring seals were failing in freezing temperatures, estimated the failure rate at roughly 1 in 100. NASA management, on the other hand, showed what investigator Richard Feynman famously called a fantastic faith in the machinery. They estimated the failure rate at 1 in 100,000. So, relying on that misplaced faith, they pushed the launch anyway, despite the blatantly known risks. And well, we know it resulted in a devastating loss of life and billions in vehicle costs.
Actually, I absolutely love this quote from Richard Feynman from that exact investigation. He said, "For a successful technology, reality must take precedence over public relations, for nature cannot be fooled."
Isn't that just incredibly profound? It's a powerful reminder that you can silence an engineer, you can manage the PR, but you absolutely cannot silence physics. Nature always wins.
And we see this exact same normalization creeping into consumer tech all the time. Look at Takata's airbags, for instance. A flawed ammonium nitrate propellant basically degraded over years of exposure to heat, essentially turning these life-saving safety devices into deadly shrapnel. It was a ticking time bomb that triggered a recall of over 50 million inflators. Or consider the infamously exploding Samsung Galaxy Note 7 batteries, which ended up costing the company a staggering £4 billion. These hidden, accepted flaws really highlight the immense, long-term financial and human costs of embedded component failures.
Let's keep moving to our third root cause, hubris and ignored warnings, the sheer danger of arrogance. Because as it turns out, overconfidence at an institutional level is often just as dangerous, if not more so, than a faulty component.
Consider the highly cautionary tale of the McDonnell Douglas DC-10. Now get this, during the design phase, it was a known fact that the cargo door could fail under pressure, and if it did, it would cause explosive decompression and physically sever the critical hydraulic lines hidden right in the unvented floor above it. Internal warnings were definitely raised, but management, they just opted for temporary band-aid fixes instead of actually doing the hard work of fixing the floor vulnerability. And this corporate arrogance eventually led to massive total loss crashes.
There's a fascinating detail here. Dan Applegate, who was an engineer on the DC-10 project, literally wrote a memo predicting these exact crashes, but it was essentially buried by the higher-ups. It really forces a tough ethical question. If you were an engineer who knew about a fatal flaw like that, would you blow the whistle against your own bosses and risk your entire career? Let us know what you would do in the comments below.
Now, you simply can't talk about hubris without talking about the RMS Titanic. The iceberg, that was just the catalyst. The engineering and operational failures are what actually made it a historic tragedy. I mean, they ignored multiple clear warnings of sea ice, they traveled at crazy high speeds of about 22 knots through an ice field, and incredibly, driven by pure institutional arrogance and an extremely tight construction timeline, they didn't even bother to carry enough lifeboats for everyone on board. It was a completely 100% preventable loss of over 1,490 lives, a tragedy so immense it literally forced the creation of modern global maritime safety standards.
And this naturally leads us into Section 4, massive-scale industrial catastrophes, when entire systems just completely fail. We are talking about the absolute largest financial and environmental disasters on the historical record.
The sheer, mind-boggling scale of these industrial failures is honestly hard to even comprehend. We already mentioned Chernobyl, rooted in an isolated, deeply flawed RBMK reactor design. That disaster cost roughly $700 billion and forced 350,000 evacuations with massive generational health impacts. Then there's Deepwater Horizon in 2010, where 4.9 million barrels of oil spilled into the ocean, costing up to $144 billion. And why? Because of overwhelming management pressure, prioritizing speed over safety. And we absolutely have to mention the Bhopal gas tragedy in 1984. Fueled by dangerously lax safety protocols, it resulted in over 15,000 deaths and 500,000 injuries, yet it only saw a relatively small $470 million settlement.
Seeing numbers like that back-to-back is just wild. Given the staggering history of industrial catastrophe, a really vital question remains. Looking at these numbers, do you think current international safety regulations are strict enough today to prevent this from happening again? Drop a simple yes or no in the comments for us.
So, where do we go from here? Well, that brings us to our final section, essential quality control lessons, learning from tragedy. Because the big question is, how exactly has the engineering community adapted their ethics to prevent these catastrophic errors from repeating?
The biggest lesson is that a tiny, seemingly insignificant detail can change absolutely everything. Take the Kansas City Hyatt Regency walkway collapse. To simplify the construction, a contractor made this incredibly simple, totally undocumented design change. They switched from using a single continuous support rod to a two-rod system. Seems harmless, right? Well, without proper recalculation, this quick fix effectively doubled the load on the supporting bolts. Those walkways completely collapsed in 1981, killing 114 people. It was horrific, but this disaster fundamentally forced the engineering community to revise their code of ethics, making sure public safety is held paramount above all else.
Now compare that dark moment to the genuinely incredible story of the Citicorp Center in New York. About a year after this massive skyscraper was built, its own structural engineer, a guy named William Lemessurier, discovered a terrifying flaw.
Because of a last-minute change from welded joints to bolted joints during construction, a severe 16-year storm could completely topple his 59-story skyscraper right in the middle of Manhattan. But here's the kicker. Instead of staying silent to protect his reputation, he immediately spoke up. He mobilized a secret $12 million retrofit, working around the clock with emergency teams to ensure the building was reinforced before hurricane season hit. It brilliantly showcases the immense, world-saving ethical responsibility engineers hold today.
We're going to wrap up today's explainer with this chilling, highly self-reflecting quote from William Mulholland. He was the chief engineer of the St. Francis Dam, which tragically failed in 1928, killing over 430 people. Looking at the devastation, he simply said, "If there is an error of human judgment, I was the human." As we continue relentlessly pushing the boundaries of technology and scaling up our massive infrastructure, we always have to ask ourselves, are we properly